9. When you divide it out, you're going to get something close to 10. It's going to cancel here. And then we still have a 40 well, this one actually might cancel out. I don't know. Let's do it to find out. So we're going to have everything with a denominator of 9, just so that we can have common. So this is going to be 3 times that, so 600 over 9. 40 over 9, what would that be? So it would be 360 over 9, and minus 10 over 9 is going to be minus 90 over 9. Now, when we do these out, we try to see if they cancel anywhere. So 1,000 minus 600, that's going to give us 400 over 9, plus that, so that's going to give us 760 over 9, and 760 minus 90 over 9 is nowhere near 0. So unfortunately, no, it doesn't work. I wish that this cubic that I picked happened to have a solution, a rational root, but it just so happens that I picked one of the many, many, many polynomials which do not have a rational root. If that's the case, I really doubt that's going to be the case on the homework because they build them otherwise, but if this happens and you have no idea what to try, this is where you would have to start employing some higher factoring techniques, which is outside the scope of this class. And so every single polynomial that you find, you should be able to use the rational root test to find a 0. Use that 0 to create a linear term that you can divide the polynomial by. So actually I'll write this down. So use rational root test to find a 0. Convert into a linear term with that 0. Divide your polynomial by the linear term, and solve for zeros if possible. If not, repeat. Right, so if we did this and I found that it has a 0 at x equals 1, then I could divide it out, and I know that I'll get some kind of quadratic term in the end, because when you divide out a cubic by a linear, it just decreases the degree by 1. So I'd have a quadratic term. Then I could try factoring that quadratic using any of the methods we know. As a last resort, I could go to the quadratic formula. And so really, all that this section amounts to is saying for any polynomial, try your hardest to reduce it down and factor it down into linear terms and quadratic terms. As long as you can do that, you can solve for the zeros of any polynomial. Unfortunately, like in the case with this one, I was not able to use the rational root test to find a 0. So in this case, I would have to employ higher level methods. But again, that's outside the scope of this class, so every polynomial you find in a homework or on a quiz or in the exams should be totally factorable using just what we learn in this class. If for some reason you have questions about things that come up in the homework or in the midterm, which we are still going to have, then come talk to me. I mean, obviously not physically because I'm in Connecticut, but go on a campus wire, email me, whatever. Just please don't just sit there and be confused. I know we don't have help sessions anymore, but I am still here. I have nothing else to do with my time. So yeah, if you have any questions, please just reach out. I'd be more than happy to help you. And yeah, that actually covers most of the notes for 3.3. Sorry, this is going to be a 4-part lecture, but my SD card ran out of memory. So yeah, that's it for 3.3.